Alright, in this video we're going to learn to solve quadratic equations by factoring. If you remember, a quadratic equation is an equation where your highest power is x squared. Learn and use the zero factor property. This is the first objective we want to talk about. If two numbers have a product of 0, then at least one of the numbers must be 0. You learned that in early arithmetic. If a times b equals 0, then either a equals 0 or b equals 0. The zero factor property works only for a product that is equal to 0. A quadratic equation, an equation that can be written in the form ax squared plus bx plus c equals 0, where a is the coefficient of your x squared term, b is the coefficient of your x term, and c is your constant. A, b, and c are real numbers. A cannot be equal to 0. This is called a quadratic equation written in standard form. If our standard form of the equation is set equal to 0, it's possible to factor the left side and then use the zero factor property where we set each factor equal to 0 to get your solutions. So to use the zero factor property, write the equation in standard form. In other words, we want everything on the left side equal to 0. Factor the polynomial if possible, using all your factoring techniques you've learned in previous algebra courses. Actually apply the zero factor property where you set each factor equal to 0 and solve. Find solutions, then check the solution in the original equation. So here's an equation, to solve, a problem to solve. It's actually already in the correct form we need. You've got it equal to 0, so this is my standard form of my quadratic, your ax squared plus bx plus c form. And since it's equal to 0 already, all I need to do is try to factor the left side. Now in this case we have a trinomial, so we remember to factor a trinomial we were able to break it down into the product of two binomials. So of course to get an x squared we will multiply x times x. And on the other numbers, the constant terms here and here. What two numbers can I multiply to make -6? Yet when I add them, I'm going to get -1. So you could think of a couple of pairs of numbers that would work there. In this case, that would be -3 and +2. Think about it. -3 times 2 would give me -6. -3 plus 2 gives me -1. So the left side is now in factored form. So to use the zero product property, we're going to set each factor equal to 0. So x minus 3 equals 0, and x plus 2 equals 0. So to solve the equation, remember we're going to do the reverse operation here. So since it's -3, I'm going to add 3 to both sides. So x is equal to +3. That's one solution. And then subtract 2 from both sides. So x would equal -2. So both of these numbers should be solutions to this original equation. Now you can always check to make sure. If I plugged in 3, that would give me 3 squared, which is 9. 9 minus 3, so that's 6. 6 minus 6 would of course give me 0. And the -2 should also check. -2 squared would give me +4. 4 minus a -2, that's like 4 plus 2, so 6 minus 6, and of course gives me 0. So both solutions check here in your original equation. Also, the fact that you have an x squared tells you should have two solutions to your equation. Let's try another. X squared minus 4x equals 0. So this is in standard form. Now in this problem we don't have 3 terms. It's not a trinomial. You don't have a constant, but you have your quadratic term, your linear term, and you're missing the constant, but it is equal to 0. So this is standard form. Now we have to see if we can factor the left side using the same method we did in the previous problem. So factoring x squared minus 4x, the first thing I can see is that there is an x in common. So if you remember general factoring rules, you're always supposed to factor out a greatest common factor first. So in this case, there is an x in common with both terms. So if I factor out an x, that would leave me an x minus, if I take an x out of 4x, I'm left with minus 4 only. So then I take each factor, now that I have each factor, set it equal to 0 for the zero product property. So x equals 0, and then x minus 4 equals 0. Now, as you can tell, x equals 0 is already solved. So 0 would be one of my solutions. And in the other one, we would add 4 to both sides. So x equals 4 is the other solution. And you could check those solutions. If I plugged in 0, I would get 0 minus 0, which is 0 for sure. Then 4 would be 16. 4 squared is 16, minus 4 times 4 is 16. 16 minus 16 would give me 0. Now this example, 9x squared equals 16. This is not in standard form. To get this equal to 0, I need to move the 16 back to the left side. So I'm going to subtract that 16 from both sides. So I'll have 9x squared minus 16 equal to 0. So now it is in the standard form we're looking for. On the left side here, if you remember your patterns from earlier algebra courses, this is the difference of squares. 9x squared is a perfect square. 16 is a perfect square, and they have a minus sign between them, which means it's a difference of two perfect squares. And if you remember the pattern that you used to factor this, the square root of 9x squared would be 3x. So we'll put that in front in the first term in both parentheses. One sign is plus, one sign is minus, always in this factoring pattern. The square root of 16 is 4. So that is the factoring pattern for a difference of squares. It's the square root of the first number, plus sign, minus sign, and square root of the second number. So I'm going to set each factor equal to 0. So 3x plus 4 equals 0. And 3x minus 4 equals 0. And solve the two equations. So if I subtract 4 from both sides, I get 3x equal to negative 4. Then, of course, we divide by the 3. So 4/3, negative 4/3 will be one of my solutions. And in the other one, it's going to be positive 4/3. It's kind of the same process, except you're going to add instead of subtract. So 3x equals 4. Divide by 3. So, of course, we get positive 4/3. Now, you could possibly write your answer instead of writing negative 4/3 and positive 4/3. Sometimes you'll see the textbook write plus or minus, meaning that you have both the positive and the negative solution. So this equation does have two answers. All right. In this example, you see it's kind of in standard form. It's equal to 0, but my equation is not in descending order. And to do your factoring well, you probably need your equation in descending order. So let's rewrite that with the highest power down. So negative x squared, negative 3x, plus 10 equal to 0. Now I need to make sure my positive term, my first term is positive, so I'm going to change the signs of everything. Change the signs of every term. So x squared plus 3x minus 10 equal to 0. So this is one of those trinomials like we had previously. If I change all the signs in an equation like this, since it's an equation, as long as it changes every sign, it's okay, it's legal. Of course, you can't change the sign of 0, so I didn't change anything there. So in this case, I have x and x, two numbers that multiply together to give me negative 10, that add to give me positive 3. That would be positive 5, negative 2. So the extractions here for your answers, x plus 5, if I set that equal to 0, I'll get x equal to negative 5. And if I say x minus 2 equals 0, if I add 2, I get x equals positive 2. Two solutions on that equation. And you could check those as well. Let's do one more example. And this one looks like it has a little bit more difficult type factoring involved in it. So let's look what we've got. The fact it's not a quadratic equation because you have x to the fourth, but maybe I can use one of the same processes to do that. So this is a trinomial. Let's see if we can break it down. For 4x to the fourth, I would say I could either use 4 times 1 or 2 times 2. I'm going to start off with 4x and squared. I'm sorry. Yeah, 4x squared in one of them and positive 1x squared in the other. That's probably going to be the best thing I can do there. And then to get a 13, how about we do a 9 times 1 to make the 9. Now let's just check that and see if that works. And my outer product will be 4x squared. My inner product will be 9x squared. 4 and 9, when they're added, makes 13. Now, this is a plus 9, but they add to make negative 13. Well, that just means that I need both minus signs. So if you'll notice, these two factors, if I multiply these together, I would get my original trinomial here. But these can be factored further because they're both the difference of squares pattern. So if I factor those further, 4x squared minus 9, that would factor as 2x plus 3 and 2x minus 3. And then the x squared minus 1, I get x plus 1 and x minus 1. So I have 4 linear factors. And if any one of those factors is 0, the whole thing would be equal to 0. So the zero product property still holds in an equation such as this. So I'm going to get 4 different solutions. And notice since my highest power was 4, I need 4 different solutions. So my solutions to this equation, if you set each of those equal to 0, on the first one you would subtract 3 and divide by 2. So negative 3 halves. On the second factor you would add 3 and divide by 2. So positive 3 halves. X plus 1, if you set that equal to 0, you're getting negative 1. And x minus 1, if you set that equal to 0, you get positive 1. So we can extract 4 solutions from that quadratic